Hey guys, today we're going to talk about patterns, relationships, and predictions when it comes to graphs. So let's get started. So, why do we use graphs in science? Because graphs can be used by scientists to look at patterns or trends within the graphs, and also that those patterns and trends that are being noticed can help scientists make future predictions, and this can even save lives or resources. For instance, this is showing the global average temperature over time, and based on the previous pattern of it increasing, we can predict that the temperatures will increase, and that's why scientists are trying to come up with solutions to global warming currently. Now, remember, correlation does not mean causation. What does that mean? If you see two variables on a graph, for instance, we're seeing ice cream sales, a line for ice cream sales and a line for shark attacks. They look like they're going up and down together. That means that they have a correlation or a relationship between each other, meaning they're both moving together, but uh, yeah, they're both moving together up and down, right? But just because they're moving together doesn't mean they cause each other. Causation is a relationship where one event causes another event to happen. To prove that something causes something else, you always need empirical evidence, which is evidence gathered for observations, experiments, research papers, and so on. So you can never assume without empirical evidence that um, something is causing another thing within your graph. You can only say, based on what you see, that there is a correlation, there's a relationship. So let's talk about the types of relationships, common relationships in graphs. We have direct relationships or positive relationships. This occurs when one variable increases, the other one also increases. And if one variable decreases, the other one also decreases. Variables are the components or the titles within the x and the y axis. So in here, the variables for me are quantity and price. And I can see that as my quantity is increasing, let's say I'm looking at 180, you can see that the price is also increasing. And if my quantity is decreasing with 10, you can see that my price is also decreasing. So they have a direct relationship. Next is the indirect relationship or negative relationships. And indirect relationship happens when is one variable increases, the other is decreasing, or when one is decreasing, the other is increasing. So they're doing the opposite thing. For instance, if you look over here, pressure, if my as my pressure is increasing towards 1000, and I can see that my wind speed is actually lower. And when my pressure is lower or decreasing, I can see that my wind speed is actually higher. This tells me they have an indirect or negative relationship, and the negative or indirect relationships normally have like a downward line. You can see that positive or direct relationships usually have an upward line. Next is cyclic patterns or trends in relationships. So you can see here, cyclic patterns look like a graph that's just going up and down like this. It's cyclic. And this is very common actually in nature, and you'll see a lot of this in earth science. We can call something cyclic when it's not only going up and down like this repeatedly, but the intervals at which they're going up and down is also about the same every time. This makes this cyclic graphs predictable. So how do you know if something's cyclic? This is a cyclic graph. This is not a cyclic graph. That's because over here, the graph is going up and down and up and down. Notice that it's not going as high up every single time. However, it's cyclic because every time it's going up or down, it's going up and down about within the same amount of intervals almost. So this is about, say, a month, and then this is another month, and this in another month. You can say that about every month or so, this graph is going up and down and then up and down. So, and this way we can predict that the graph will probably go up next and then down next. But this is not a cyclic relationship. Why? Because yes, it's going up and down. This is showing the percentage of copper with the depth, how deep you're going under the earth. It is going up and down, but not at the same intervals every time. It's random. So the intervals at which the cyclic graphs are going up and down matters. That's what makes them cyclic. You can predict what will happen, but you can't do that with non-cyclic. Next is a constant pattern or trend in a relationship. Constant pattern is when one of the variables change but the other stays the same. For instance, you can see here, as my air pressure is going from 0 to a higher number, my altitude is staying the exact same number. If we pretend that this number is 5, my altitude is always 5, no matter how much my air pressure is increasing. Same thing over here. You can see that as my altitude is increasing, my air pressure is staying the same amount. So it can be horizontal or a vertical line. Next is a fluctuating pattern. Remember when we talked about this graph being non-cyclic? So what would we call this graph? We would call this fluctuating. This is when a graph just fluctuates or changes, kind of like this, but it's random. There's no regular interval to it. For instance, this is showing the extinction rate millions of years ago, and you can see that the extinction rates is not consistent and doesn't have a consistent interval between the ups and downs, peaks and troughs of this graph. That's when we say this is a fluctuating pattern. That's it.